Kia ora. This is a really good question that Cohen sent in, and it's from the June 2022 Pure 3 paper. The examiner's report notes that very few students could do the second part of this, which is 8b. So before I start, I just want to go over one really basic thing that I think some of you might have forgotten, and that's a thing from all the way back when we first do coordinate geometry. I'm just going to draw a line, a straight line, and I just want to have a look at what we can say about the gradient of that line. So let's put in a line anywhere really. Okay, let's just call that line y is equal to 3x plus 2. Right, so the gradient of that line is 3. Now, if we look at how we can interpret that gradient in terms of the tangent, if we take the angle here made by the positive direction of the x-axis in that straight line, we can see, doesn't matter where we draw the triangle in, that we've got a gradient of 3, which means out 1 and up 3. And we can make that into a right angle triangle, right? So we can do that at any point, any 2 points along that line, we can form a little triangle like that. And if we're trying to measure this angle here, theta, we can say that tan of theta is equal to 3 over 1, which is the same as m. And if you remember that, that's the key to the second half of this problem with a little bit more complication, obviously. Okay, so the first part is a pretty straightforward implicit differentiation question. We have to express dy by dx in terms of x and y. Now, often in the Cambridge exams, they give you the gradient that you're heading for. In this case, they just want you to do it, but it's pretty straightforward. So off we go. We get 3x squared plus 3y squared times dy by dx. So we're using the chain rule to help us differentiate with respect to x, and then we've got a product here, 2xy, so it's going to be 2x times dy by dx plus 2y. 8 differentiates to 0, and so does 0, so that's what we get there. Now, quickly collecting up like terms, we get dy by dx into 3y squared plus 2x is equal to negative 3x squared minus 2y. I'm doing this bit quickly because I think most of you are pretty confident with implicit by now. If you're not, go and watch one of the slower implicit videos. So the last step in here is to say that we can write dy by dx as, well, we can leave it like that, or we can factor out the negative, and then we get 3y squared plus 2x. So as usual, there's some kind of nice symmetry stuff going on in there. Right, now look at the second part of the question. The tangent to the curve at the point where x equals 0 and the tangent at the point where y equals 0 intersect at the acute angle alpha. So we don't have to draw this curve up here, but I think it helps at this point to have a look at what's going on where x is equal to 0 and where y is equal to 0. And if we visualize those two tangent lines, I think this question becomes really, really easy. So when x equals 0, we can easily figure out the y coordinate. We're going to have y cubed plus 8 is equal to 0, which gives me y is equal to negative 2. So the coordinate is 0, negative 2, and we can work out the gradient of that tangent line. Right, so at x equals 0, the gradient of the tangent will be negative 0 plus, what have we got? Oh, we've got 0, negative 2 for my coordinate. So 0 plus, what am I doing? Oh, I know what I'm doing. Sorry, backing up. Just let's not substitute yet. You can substitute now, but I didn't do it like that before. So when x is 0, our gradient is simply negative 2y over 3y squared. That's better, which equals negative 2 over 3y. And at x equals 0, we know that y is equal to negative 2. So we get negative 2 over 3 times negative 2. So my gradient is m is equal to 1/3. Right, and we can do the same thing where y is equal to 0. So when y is equal to 0, we can find the x coordinate. We've got x cubed plus y cubed plus 2xy plus 8 is equal to 0. So we have x cubed plus 8 is equal to 0, giving me x is equal to negative 2. So my coordinate is negative 2, 0. And my gradient So dy by dx was equal to this. So substituting in y is 0 and x is -2, we get negative 3x squared on 2x, which is equal to negative 3x over 2, and x is -2. So negative 3 times -2 over 2 gives me a gradient of 3. So I guess all I did from here, those steps seem to me pretty obvious ones. And then I did a very quick sketch to see what was going on. So if we just draw in a set of axes, some of you won't need to do this, but I think for most people this will help you understand what's going on. So we've got the gradient to the tangent that goes through 0, -2, and we know that that's got a gradient of 1/3. So we can draw that in. X is 0, y is -2. We've got a line that looks like this. And at -2 and 0, we've got a gradient of 3. So if I work back here, we know it goes through that point, and we know it's got a steep gradient. Should have done a different colour. So the angle that we're looking for in here is alpha. But if I take my ruler and just draw in a dotty line, we can use the thing that I started off with first. Right, sorry, I'm probably giving people motion sickness by this ruler thing. Let's just move the screen up, and now I'll move the ruler up. Right, well, let's have a look at what we've got. If we call this angle here, I'm going to call this beta. No, I'm not going to call that a Greek letter. I'm going to call that big B, capital B. And then this one here, I'm going to call capital A for the whole thing. Right, so we know that tan of A is equal to 3, because that's m for my first line. And we know that tan of B is equal to 1/3, right? So that's m for my second line. And then alpha is just angle A minus angle B. So we can use our compound angle formula here. We're asked to find the exact value of tan alpha. So it must be the same as tan of A minus B. And I can hear some of you at this point just like ditching the video because you can see exactly what to do from here. And I guess that's fine, right? So for those of you still here, we get tan A minus tan B over 1 plus tan A, tan B. And tan of A was 3, tan of B was 1/3. And then we've got 1 plus 3 times 1/3. So working all that through gives me 8/3 in the top line, numerator, divided by 1 plus 1, which is 2, which is 8 over 6, which simplifies down to the answer in the schedule, which is 4/3. So great question. I think there's heaps of good stuff in there. And as the examiner's report said, this was a bit different and most students just didn't really know where to attack it. But hopefully most of you do, as long as you link all of the different parts of level 3 calculus and the A-level course up together, right? So the key things in here that you need to have kind of in your toolbox are this idea that the gradient of the line is tan of theta. You need to be confident with implicit, and you need to see the value in drawing a simple sketch to work out how you can link all of those ideas together. Thanks for watching. Keep on sending in your questions.